Today I'm going to explain to you how to compare community diversity. To be able to compare community, we first need to understand what to count as an abundance because we can count different things. For instance, we can count the number of individuals, but in some cases, for instance, we have trees and spruces. It's very difficult to understand what is an individual and what is another individual. That is, what is the difference between two individuals. So, in this case, we count, for instance, the modular units or densities instead of individuals or biomass, or for instance the percentage of coverage. We can use squares, we can use different sampling techniques. In any case, we need a surrogate of abundance to account for the difference in biodiversity between different samples. Now the question is, which method uh, should be used to compare the communities? One of this is the rank abundance plot. As I show you, the rank abundance plot is very interesting because you can use two different courses to understand which one is richer than the other, which one has more species, or which one is even. The Kolmogorov-Smirnov test is another way to have a statistical variable to understand the difference. So if the difference is statistically relevant or not, you can use richness estimation. For instance, the Kao 1, Alpha Fisher, jackknife, because they estimate the affected number of species and are very useful to understand. Which community is richer than the other one? Another way is to use species area curve as a cumulation curve or rarefaction curve to understand the differences in community. Or we can use the species abundance distribution and calculate the Alpha Fisher. We could have three different scenarios. The first one is that we have areas of same dimensions sampled from similar ecological communities. The second one is that we have areas of different dimensions or samples from different ecological communities. The third different scenario is that we can have a small dimensional sample that very often and has number of individuals less than 100 or 200. In the first scenario, the area of the measured samples from similar ecological communities, we can use richness and abundance such as S or N to compare communities. It's a very useful index to compare the evenness of the two samples is the EH, and the slope of ECDF as a graph as the intercept if n of each sample is more than 100 individuals. And if you want to understand the difference in dominance and rarity, you can just use the relative dominance and the percentage of rare number of individuals divided by number of species. So PCT rare n divided by S. For the second scenario, where we have areas of different dimension or samples from different ecological communities, we can use the values to estimate the difference in the richness and abundance by the Margalef index or the Alpha Fisher index. if n of each sample is greater than 100, or where the Smith-Wilson index can be used to compare the n or the abundance. If we want to understand the difference in the evenness, we can use evenness of Shannon or the M of ECTF. So there's if you want to understand the difference between dominance and rarity, you can use the absolute or relative dominance and the percentage rare at 1 or 5%. In the third case, where the sample area are of more dimension, means that the number of individuals is less than 100 or 200, we can use to evaluate the differences in diversity between the two samples by the Hulbert-Simpson index. That is very scalable in case more dimension samples, and we can use 1 minus d, so 1 minus the Hulbert-Simpson index. To evaluate the differences in evenness, instead we can just use this evenness. For the evaluation of dominance and rarity, relative dominance or McNaughton index is very useful. And for rare species, the PCT rare 5% or the PCT rare n divided by S are very useful indicators. Moreover, we can use statistical tests to understand if these differences between communities are more or less statistically evident. And one of these tests to understand if the difference between communities is statistically is more or less statistically evident or not is the t-test or the ANOVA test to compare two or more communities in case of normal data distribution. If normality cannot be ensured, then we have to take the help of jackknifing process. Now, to use jackknifing process, which is very simple, we need just to calculate the diversity, either the Shannon or the Simpson. Any one will do. We can use one or any one of them, and then add up all the samples together to obtain a kind of original diversity estimation. Then we calculate n times the diversity, excluding each time only one sample to obtain minus 1 or minus j. Then we calculate the set of values for each n sample, that is just nst minus n minus 1 of into stj or sti, depends on what is your sample. So we will remove from the original diversity estimation. The diversity of each sample we remove, and we estimate the diversity by the jackknifing as the sum of this pseudo values divided by n. That is the total number of samples. In this way, we can also calculate the standard error, that is the standard error of the estimation of jackknifing process. We have a variable statistics to provide information about the evidence in differences in statistical communities. So here I tried to show you how to compare different communities based on richness and abundance, based on evenness, and based on the dominance and rarity. I hope you will use these tools to compare the data and evaluate difference in your biodiversity data. So see you next time. Thank you.